Welcome to our comprehensive course on DevOps tools. I'm excited to guide you through two powerful tools that are revolutionizing the way we handle infrastructure and automation, Consul and Ansible. In this section, we'll focus particularly on Consul, a sophisticated service mesh solution that's becoming increasingly crucial in modern distributed systems. Whether you're new to DevOps or looking to expand your toolkit, this course will provide you with practical, hands-on knowledge that you can apply immediately in your work. Let's begin this journey together into the world of modern DevOps tools and practices. Let's dive into Consul, a powerful tool in the modern DevOps landscape. Consul represents a significant evolution in how we manage distributed services and applications. At its core, Consul serves three fundamental purposes. It's a distributed service mesh, a robust service discovery platform, and a reliable key value store. Think of it as a central nervous system for your distributed applications, helping different services find and communicate with each other efficiently and securely. What makes Consul particularly valuable is its ability to handle modern dynamic applications where services are constantly being deployed, scaled, and updated. It provides a centralized control plane that manages how these services communicate, making it easier to maintain and scale complex distributed systems. Whether you're running applications in a single data center or across multiple cloud providers, Consul helps ensure smooth, secure, and efficient service-to-service communication. Now, let's explore the key benefits that make Consul such a valuable tool in your DevOps arsenal. First and foremost is service discovery. Imagine having dozens or hundreds of services that need to communicate with each other. Consul automatically handles the complex task of helping these services find each other, eliminating the need for hard-coded IP addresses or manual configuration. The health checking and load balancing capabilities are particularly impressive. Consul continuously monitors your service's health and automatically routes traffic away from unhealthy instances, ensuring your applications remain reliable and responsive. The distributed key value store is another powerful feature, acting as a central repository for configuration data that all your services can access. Perhaps most importantly in today's security-conscious world, Consul provides robust security features through mutual TLS encryption. This means all service-to-service communication is encrypted and authenticated, helping protect your applications from potential security threats. These features work together to create a comprehensive solution for modern application networking challenges. Let's explore where and how Consul truly shines in real-world applications. In modern software architecture, Consul has found its sweet spot in several key scenarios. As a service mesh, it excels in environments where you need transparent, secure, and observable communication between services. This is particularly valuable in microservices architectures, where you might have dozens or even hundreds of services that need to communicate efficiently. Consul is especially powerful in multi-cloud and hybrid environments. Imagine running some services in AWS, others in Google Cloud, and still others in your on-premises data center. Consul provides a consistent way to handle service communication across all these different environments, making it much easier to manage complex distributed systems. In highly dynamic environments, where services are constantly being scaled up or down, Consul's automatic service discovery and health checking capabilities become invaluable. This makes it particularly useful in industries like e-commerce, financial services, and technology companies where application demands can change rapidly. It's important to understand not just when to use Consul, but also when it might not be the best fit. Let's be honest about the challenges and limitations you might face. First, there's a significant learning curve involved. Consul introduces concepts like service mesh, discovery, and distributed key value stores that might take time to fully grasp, especially if you're new to distributed systems. The deployment complexity is another consideration. Setting up and maintaining a Consul cluster requires careful planning and expertise. You'll need to think about things like cluster size, network topology, and failure scenarios. This operational overhead might not be justified for simpler deployments. Speaking of simpler deployments, if you're working with a small application with just a few services that rarely change, Consul might be overkill. In such cases, simpler solutions like DNS or basic load balancers might be more appropriate. Understanding these limitations helps you make informed decisions about when to use Consul and when to consider alternatives. Let's talk about what it takes to get started with Consul and set realistic expectations about the learning journey ahead. Getting comfortable with Consul requires a moderate investment of time and effort, but don't let that discourage you. The benefits are well worth it. You'll need a solid foundation in several areas. First, networking concepts are crucial. Understanding IP addressing, DNS, and how ports work will make your learning journey much smoother. You should also be comfortable with basic distributed systems concepts, as these form the theoretical foundation for many of Consul's features. Command line interface experience is essential, as you'll be using the CLI frequently to manage and interact with Consul. Additionally, familiarity with JSON or YAML is important since these formats are used extensively in Consul's configuration. Remember, you don't need to be an expert in all these areas to start. What's important is having a basic understanding and being ready to learn as you go. The skills you develop while learning Consul will be valuable not just for using this tool, but for your broader DevOps career. One of the great things about Consul is the wealth of learning resources available to help you master it. Let's explore the various paths you can take to deepen your knowledge. The official Consul documentation should be your first stop. It's comprehensive, well-maintained, and regularly updated with new features and best practices. The Consul Learn guides provided by HashiCorp are particularly valuable because they offer hands-on, practical tutorials that walk you through real-world scenarios. These guides are structured to take you from basic concepts to advanced implementations step by step. For those who prefer a more structured learning approach, the HashiCorp Consul course on Udemy provides video-based instruction that can help you understand complex concepts more easily. The hands-on tutorials available through learn.hashicorp.com are especially useful because they let you practice in a safe, controlled environment. I encourage you to bookmark these resources and refer to them regularly as you progress in your Consul journey. Remember, learning is an iterative process. Start with the basics and gradually work your way up to more advanced concepts. Now, let's talk about getting Consul installed on your system. One of the great things about Consul is that it's platform agnostic, supporting Windows, Mac OS, and Linux. The installation process is straightforward across all platforms, but there are some key differences to be aware of. For Windows users, you'll be working with zip archives and need to handle path environment variables. This might seem a bit technical if you're new to it, but don't worry, we'll walk through it step by step. Mac users will find the process familiar if they've installed other development tools, and Linux users will appreciate the straightforward nature of the installation process. What's particularly important is understanding where Consul is installed and ensuring it's accessible from your command line. This means adding the Consul binary to your system's path, which we'll cover in detail. The goal is to have Consul readily available whenever you need it, regardless of which directory you're working in. Remember, this is just the beginning. Once installed, we'll move on to configuration and actually using Consul in real-world scenarios. The installation is your first step toward handling service discovery and mesh networking like a pro. Now we're getting to the exciting part, actually using Consul to register and discover services. This is where you'll start to see the real power of Consul in action. Let's break down the key operations you'll be performing. First, you'll learn how to start the Consul agent, which is the core component that handles service registration and discovery. Think of it as the foundation that everything else builds upon. Then, we'll explore service registration. This is where you tell Consul about the services you want to manage. You'll learn how to specify important details like service names, IP addresses, ports, and health check settings. One of the most powerful features we'll cover is service discovery. You'll learn how to use Consul's API to find services in your network dynamically. This is particularly valuable in environments where services might come and go, or where you need to maintain high availability. The examples provided, such as using curl commands to interact with Consul's API, give you practical, hands-on experience. These are skills you'll use regularly when working with Consul in production environments. While we hope you'll find Consul invaluable and want to keep using it, it's important to understand how to properly uninstall it if needed. The uninstallation process varies slightly across different operating systems, but the principles remain the same. The key steps involve stopping any running Consul processes or services first. This is crucial to prevent any potential issues. Then you'll remove the Consul binary and any associated configuration files. This cleanup process ensures that no remnants are left behind that might cause conflicts in the future. What's particularly important is understanding the impact of uninstallation, especially in a production environment. You'll need to ensure that any services depending on Consul are properly reconfigured before removal. This knowledge is valuable not just for uninstallation, but also for understanding how Consul integrates with your broader infrastructure. Remember, even if you uninstall Consul, the knowledge and experience you've gained working with service mesh and service discovery concepts will remain valuable in your DevOps journey. As we transition from Consul to our next tool, let's introduce Ansible, another powerful piece in the DevOps toolkit. Ansible represents a different but complementary approach to infrastructure management, focusing on automation and configuration management. What makes Ansible particularly interesting is its simplicity and agentless architecture. Unlike many other automation tools, Ansible doesn't require you to install agents on the systems you want to manage. Instead, it uses SSH or WinRM to communicate with target systems, making it lighter and easier to get started with. The open-source nature of Ansible means you have access to a vast community of users and contributors, along with numerous pre-built modules and playbooks. This community-driven development ensures that Ansible stays current with modern infrastructure needs and best practices. As we delve deeper into Ansible in the coming sections, you'll see how it complements tools like Consul, creating a more complete DevOps ecosystem for managing and automating your infrastructure. We're now transitioning to Ansible, a powerful automation platform that has transformed the way organizations handle infrastructure management and application deployment. This section marks an important shift in our discussion from service discovery to automation and configuration management. Ansible represents a significant evolution in the world of automation tools. Its agentless architecture and simple YAML-based syntax have made it a preferred choice for organizations of all sizes. As we explore Ansible, you'll understand why it has become such a crucial tool in the DevOps toolkit. The principles we'll cover in this section will lay the groundwork for understanding modern infrastructure automation. Whether you're managing a handful of servers or thousands of nodes across multiple clouds, the concepts you'll learn here will be invaluable. Understanding where Ansible shines in real-world scenarios is crucial for effective implementation. Let's examine some typical use cases across different industries. In configuration management, Ansible excels at maintaining consistency across large server fleets. Consider a scenario where you need to ensure specific security configurations across hundreds of servers. Ansible's idempotent nature means you can run these configurations regularly to prevent drift, ensuring compliance with security standards. For application deployment, Ansible's role-based structure allows you to create reusable deployment patterns. Infrastructure provisioning with Ansible becomes particularly powerful when combined with cloud platforms. You can automate the entire lifecycle of your infrastructure, from initial provisioning to ongoing maintenance and eventual decommissioning. This becomes especially valuable in hybrid cloud environments where you need to maintain consistency across different providers. In financial services, Ansible may be used to automate complex trading platform deployments where consistency and speed are crucial. Healthcare organizations use it to maintain IAPI compliance across their infrastructure. Manufacturing companies leverage it for IoT device configuration and management. A particularly interesting case involved a telecommunications company that used Ansible to automate network device configuration across their global infrastructure. They reduced configuration errors by 90% and cut deployment times by 75%. Before diving into Ansible, let's consider its practical implications. The learning curve, while not steep, requires investment in understanding YAML syntax, playbook structure, and Ansible's approach to automation. This initial learning phase is crucial for effectively utilizing the tool. For simple tasks on single servers, Ansible might be more than you need. Shell scripts or simple configuration management tools might be more appropriate. Additionally, Ansible's focus is on configuration management and orchestration rather than real-time monitoring or event-driven automation. Understanding these limitations helps in deciding when to use Ansible and when to consider alternatives. This knowledge is particularly valuable when designing your automation strategy and choosing the right tools for specific scenarios. Success with Ansible requires specific foundational knowledge and dedicated learning time. The moderate effort needed to master Ansible includes understanding YAML syntax, playbook creation, and module usage. This investment typically spans several weeks of consistent practice. Essential prerequisites include basic Linux/Unix command line skills. You should be comfortable navigating directories, managing files, and executing commands. YAML syntax knowledge is crucial as it forms the backbone of Ansible playbooks. System administration concepts, including understanding of servers, networks, and services, round out the fundamental requirements. This combination of skills creates a solid foundation for effectively using Ansible in real-world scenarios. The good news is that these skills are highly transferable and valuable across many DevOps tools and practices. A wealth of resources is available for mastering Ansible. The official Ansible documentation serves as your primary reference, offering comprehensive guides and best practices. For hands-on learning, the Ansible for DevOps course on Udemy provides structured, practical training with real-world examples. Red Hat's Ansible Learning Path offers a systematic approach to learning, from basics to advanced concepts. These resources complement each other, allowing you to choose the learning style that works best for you. The knowledge gained from these resources empowers you to automate infrastructure management, streamline deployments, and implement efficient configuration management practices. This expertise becomes increasingly valuable as organizations continue to embrace automation and DevOps practices. Installing Ansible marks your first practical step into automation. The process varies by operating system, but we'll focus on Ubuntu as an example. The installation uses standard package managers, making it straightforward and reproducible. After installation, verifying the Ansible version ensures everything is set up correctly. This verification step is crucial as it confirms that Ansible is properly installed and accessible from the command line. These installation skills transfer to other systems and tools, building your DevOps toolkit. Understanding the installation process helps with troubleshooting and maintaining Ansible in production environments. Creating and running Ansible playbooks is where theory meets practice. A playbook, written in YAML, defines the desired state of your systems. The structure includes hosts to target, tasks to perform, and optional parameters like privilege escalation. The Ansible playbook command executes these configurations, applying them to your infrastructure. This process is idempotent, meaning you can run it multiple times safely, and Ansible will only make necessary changes. This knowledge forms the foundation for automating various IT tasks, from simple server configurations to complex application deployments. As you become more comfortable with playbooks, You'll discover their power in maintaining consistent infrastructure states. Let's examine a practical example of an Ansible playbook that sets up a web server. This playbook demonstrates key concepts: host targeting, privilege escalation, and task definition. The tasks include installing Apache, copying content, and ensuring the service runs. Each task uses specific Ansible modules: apt for package management, copy for file operations, and service for managing system services. The Become Yes directive shows how to handle privileged operations securely. This example serves as a template for creating your own playbooks, illustrating best practices in playbook organization and task definition. You'll use similar patterns when automating your own infrastructure tasks. Understanding playbook structure is crucial for effective automation. The example playbook demonstrates essential elements: a descriptive name, target host specification, and privilege escalation settings. The task section contains the actual automation steps. Each task focuses on a specific objective, using appropriate modules for different operations. The progression from installation to configuration to service management shows logical task ordering. This structured approach to automation ensures maintainability and reusability. You can adapt this pattern to automate various infrastructure components, from web servers to database systems. While Ansible usually becomes a permanent part of your toolkit, understanding the uninstallation process is important for system maintenance and troubleshooting. The process varies by package manager: apt for Debian-based systems, Homebrew for Mac OS, and Chocolatey for Windows. Proper uninstallation ensures clean system states and prevents conflicts with future installations. This knowledge is particularly valuable when upgrading Ansible or maintaining development environments. Remember that uninstalling Ansible doesn't affect the systems it is configured. Your automated configurations remain intact. This separation between the tool and its effects is a key feature of Ansible's design. We've covered significant ground in understanding both Consul and Ansible, two powerful tools in the DevOps ecosystem. Now's the perfect time to reflect on what you've learned and consider how these tools might fit into your own workflows. Think about scenarios in your current or future projects where service discovery with Consul could solve communication challenges between microservices. Consider how Ansible's automation capabilities could streamline your deployment processes or configuration management tasks. I encourage you to try implementing a small proof of concept with either tool. Perhaps start with a simple Ansible playbook to automate a basic server setup, or experiment with Consul service discovery in a local development environment. Remember, mastering these tools takes practice. Don't hesitate to revisit any concepts we've covered or explore the additional learning resources provided. What specific aspects of Consul or Ansible would you like to explore further?